So if you're still watching the videos up to this point, you're either one, being assigned to do so by some teacher or something, or two, you're trying to really learn this stuff and it's exciting to you. I hope it's the latter, because it is really exciting. Anyway, let's do another binary value here, and I'm just going to drop some binary numbers up here, so on and so forth. We could go for a ways here, but I think I'll stop there. So what is this? What does this represent? Well, remember, this is 1, 2, 4, 8, 16, 32, 64, 128, and I could keep going, 256. Alright, hopefully the number 256 might ring a bell. You have 256 gigs of whatever, blah, blah, blah. That's because we're thinking in twos again. Anyway, if I had that digit, that would be 256, but we don't, so I'm going to take that digit off. Well, I can write this out this way every time. I say 1, 2, 4, 8, 16, 32. Or I can use exponents to do that. And so I'm going to actually write this out in its exponent terms. This is 2 to the 0, 2 to the 1, 2 to the 2. That didn't go very well. Let's try again. 2 to the 3. Okay, 2 to the 3 is 8. 2 times 2 times 2 is 8. This is 2 to the 4. 2 times 2 times 2 times 2 is 16. Guess what this next one is? Well, it's 2 to the 5th, 2 to the 6th, and 2 to the 7th. Alright, so there we go. I can either think of it as 1, 2, 4, 8, 16, or the equivalent is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. This is nice and succinct, I think. That's kind of nice. But then maybe this way has more meaning when you're converting to decimal. If you don't know what exponents are, let me refer you to a place where you can learn about them and or review them. Right here. This is one of my favorite websites ever, probably yours too, I hope. It is KhanAcademy.org, and I refer to these videos a lot for my own videos, simply because he does an excellent job explaining the concepts. Anyway, here, if you search here for exponents, you'll eventually come to this exponent whole lesson plan here, which is nice. You can learn about exponents. He takes you through. You can work the problems, that sort of thing. So search for exponents and come here and work out some exponent problems. But anyway, coming back to what we had here, this is 2 to the 0, 2 to the 1, 2 to the 2. Well, how does this compare to our decimal we were doing? We had a number, I can't remember the exact, maybe it was 3964 or whatever. But we had this decimal number, 3,964. How does that compare to what we're doing up here? Well, again, this was 1, and this was 10, and this was 100, alright? And this is $1,000 bills. And let's actually add one more digit. Let's get a nice big number here. Let's do, I don't know, let's do a 1 out here. And so that 1 represents the 10,000th place. Okay, 10,000. Alright, notice we're just gaining a 0 each time. And going back to my dollar bill examples, it's 4 $1 bills, and 6 $10 bills, and 9 $100 bills, and 3 $1,000 bills, even though they don't really exist, and 1 $10,000 bills. That'd be a nice dollar bill to get my hands on. Anyway, and then when you throw all those dollars in a pile, and we'd have $13,964. Well, what is this going compared to what our base 2 system up here is? Well, it's 10 to the 0. This is 10 to the 1. This is 10 to the 2. This is 10 to the 3. And this is 10 to the 4. And 10s are kind of easier to think about here, because every time I would say 4, well, that's 4 zeros after 1, and 3, that's 3 zeros after 1, and 2, that's 2 zeros after 1, so on and so forth. But notice here, we're going 0, 1, 2, 3, 4. We're just adding another 10 or power of 10. We're adding another power of 10 as the digits increase here. And here we're adding another power of 2 as the digits increase. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, same idea down here, except, drum roll, what is the base difference between this and this? Well, the base in this case is 10, and the base in this case is 2. Okay, so that's why we say it's base 2. And here we're saying it's base 10. Okay, binary, decimal, right? Or base 2 base 10. So that's a more succinct way of thinking about that. Anyway, all right. Number bases, and you can have any kind of number base. So base 8, we'll talk about base 16. You can base 7, but any number can be the base. But we'll deal with primarily binary or base 2, base 10, which is what we're used to, and then we'll get to base 16 numbers eventually.